Did I pick it up from your table? Yep. Yes, I did. Oh, okay. Maybe we'll have less load on each of us. Yeah, thank you, Adam, for showing up. Even if you miss to do homework, your presence is really appreciated. If you did it, it is appreciated in twice the amount. Because we need not only the authors of homeworks, but also graders. Oh, well, you can keep it hidden and write unknown hero. Okay. Yeah, thank you. So let's count how many do we have? So 1, 2, 3, 4, 5, 6, 7. Other volunteers who really want to do double grading? Okay, yeah. Oh, I have 2 volunteers. Excellent. Oh, happy to see you. Happy to see you. Please come on in. Okay, then I think only Nate will be double grader today. Oh, you. So by quickly glancing through what you did, I already got an impression that, to my surprise, this homework, well, you previously performed well, and this you performed even better. When I was trying to do it myself, it was kind of complicated years ago, but I think the explanation is that everyone in this class is really well prepared mathematically, and we only need concepts from the subject, but mathematically you perform really well. So let's devote this meeting to grading of this homework. So here is the schedule of grades. At the end of this activity, please add together all points. Problems from 1 to 5 should add together 200, and extra credit gives safety cushion, so that it like maximal is 100 over 100, which means like 10 pluses. 100 over 100 is sufficient. Okay, I will go over the answer key and give comments for which aspects you should give credit, for which withdraw. And I noticed that most of the class attendees did it correctly, but kind of very dry as a freshman assignment. Here's the problem, here is my answer. Here, and I do not have any way to catch it, but you may try to credit each other if you see comments, like an attempt to analyze the solution. A verbal comment, how to interpret, and what we do see in the answer. It's if it is missed, do not punish, but if it is present, give a credit. Okay, draw the function. Well, I think it is related to high school activity, so one can separate factors, put linear outside, have a quadratic, find roots, and see that this function crosses the x-axis 3 times, zeros and plus minus 0.8 something, and then one can look that to the very right from zero, it will be, everything will be positive, and then it alternates sign, and everything is multiplied by Gaussian shape, so that at the infinity it goes to zero. So what was the schedule? Okay, 10 points. Comment. Well, this is chosen as a polynomial related to the third excited state in harmonic oscillator, and comment is the higher the number of eigenstate, the higher the number of nodal points, or denser the fringes, which corresponds to more vivid motion, higher kinetic energy, right? Denser fringes means higher momentum. Okay. Next, find expression where we have Gaussian exponential without minus sign, and derivative of nth order in between. So we are doing it as a little game and exercise, but this thing is kind of advanced topic, which is often excluded even from graded classes. So this is so-called generating function, which has a compact form, and it generates polynomials. It generates polynomials of different order depending on number n, and the eigenstates of harmonic oscillator are polynomial times Gaussian exponential. This function generates polynomials equal or very similar to the polynomials in eigenstates of the harmonic oscillator, and here in this 25-point task, we explore mechanics, how it works. So if we have zeros order, then these two exponentials cancel each other, and we get one. So it's polynomial of zeros order. And if you have order more than one, then by sequence of several derivatives, we get derivative of this x squared and what is coming out. But later on, exponentials still cancel each other, and we have a pure polynomial. So in the first order, it will be linear x. In the second, it will be x squared minus 1. And the third will be x cubed minus 3x. So the if one wants to find it in texts on math or Wikipedia, it's Rodriguez formula. And if you see this escalating polynomials of different order, absolutely correct, give full credit. If there is something wrong with signs or coefficients, but still you have the order like going zeros first, second, third, give partial credit. And be creative how to credit any comments if there are observations and connections between this equation and eigenstates of harmonic oscillator. Question number 3, 25 points worth. So here we are taking the first excited state, which is between ground state and second excited. And we are removing all coefficients and dimensionalities to make it a little simpler. But the goal of this little exercise to see math and mechanics, how one can generate either ground state or second state by applying annihilation and creation operator, right? So if one applies the stuff with minus sign between x and ddx, then there is a constructive addition of the square factor, and we come to the polynomial of the second order. If we have minus here, the construction of this x square second order is the addition of the second order is destructive, right? So they cancel, and we get zeroth order, all multiplied by this decreasing Gaussian exponential. So if the answer is correct, give full credit. If there are some errors, withdraw something and give some extra credit if you see comment and connection to the eigenstates of harmonic oscillator and either exciting higher up to the second state or de-exciting back to the ground state. Okay. Number 4, 30 points worth. So the question is, does this combination of differential operators represent any observables? Well, plugging in is or opening the bracket is not as complicated, but the questions that some of you sent by email probably were not about the math, but about the interpretation. So by now we do not know too many operators. We know only a few, right? And after processing, opening the bracket, by the way, one can identify that the cross term or derivative times position and position times derivative represents looks very similar to the commutation that should give 1, right? And then we do have 3 terms: second order polynomial square, the second derivative, and a constant. So among the 4 observables from real world, we know position, momentum, kinetic energy, potential energy. So the square is potential energy for oscillations, right? So if I'm not sure about exact points, but maybe like 10 points from math. 10 points for telling that x square is potential energy, and 10 points for telling that second derivative is kinetic energy, right? So if there is a word kinetic energy, plus 10, if there is a word potential, plus 10, if you see this expression, plus 10. The constant should be interpreted as 0-point energy, because even if harmonic oscillator has is in the ground state, the energy is not non-zero, and actual value will be different from here. But by formulating this problem, we didn't set up exact values, so it's only a model of Hamiltonian. If we carefully put all bells and whistles, it will be what it should be. Okay. Then problem 5, 10 points. So maybe 2 points per example. So to get the full credit, one needs to give at least 5 examples, because we went over them. And I noticed by quickly glancing through from what you submitted, probably this will be the problem where you will withdraw points from each other, because I saw like 1 or 2 examples, and the expectation was to put as much as possible. So I'm not telling that I'm giving the full list. You may find more than 5. So vibrations, the interatomic distances in a molecule near equilibrium, the change of orientation of polar molecule in a solvent vibration. Okay, ball and spring. I completely with you if you cannot read my handwriting, because I cannot read it myself. Plasmons, when in the metal nanoparticle, the cloud of electron collective electronic motion goes forward and backwards. Does any of you do research with metal nanoparticles? Is there anyone doing undergraduate research at the group of Professor Zhangui Yang? No, okay, but there are active research at our department as well, and it's one of the popular branch of nanoscience. When instead of semiconductors, one takes like small pieces of gold, and they're bright. Although gold is a metal, which is should have 0 gap, and by our molecular view, it should be like black and dark. Should absorb light but not emit. Should absorb everywhere, as because typical in most materials, band gap defines the frequency, and gold has 0 gap, but it's still optically active. And there is a different mechanism. Instead of going like from HOMO to LUMO, it just takes many electrons and they collectively move, oscillate with given frequency, and it defines the color. This was used historically in the stained glasses in religious buildings, when one wants to have some pictures that look through the glass by melting glass with this gold nanoparticles, which was possible to do in ancient times. One get nice colors like from green to red. LC circuit, one which all of us have in cell phones and any radio transmitters and receivers. Electric, well, the amplitude of electric field in lasers. If you have mode of electromagnetic radiation between 2 mirrors, which is a key for laser, one can, it basically oscillates. So if one looks on the amplitude of electric field, it oscillates with the frequency of light. So it's another example of an oscillator. Okay, number 6 for extra credit. I think, let me check if I give details. No, I hidden the mechanics of taking this integrals, but I promise I did it in my time. So if you see the one splits, what was the goal? The goal was to normalize second excited state. So one takes wave function absolute value squared, changes variables, and then it's an integral of polynomial with 3 terms, and then exponential partial, and we split it on 3 integrals. So maybe, since it is already extra credit, give partial extra credit if answers is correct, if it is similar what is shown here, but give like 30 out of 40 for correct answer, 10 if you see the derivations, how these integrals are taken by part. Okay. Now please add together all grades that you've computed, that you graded. Joshua and Allison, please do the same and then email me the results of your grading. And is everyone correct, or you need more time? Who needs more time to add numbers? Okay, that's fine. And let me check if I have slides for any entertainment or. I'll make few comments, but we will not stay here for the full hour, because you need to accumulate energy for the evening lab, which is kind of important. Done? Yeah. I done adding or need a little more? Oh, thank you so much. Oh. Well, if you see this, can you go one before? One up, 10. Okay. Thank you. Yeah, thank you. I'll keep it over the weekend just to enjoy and bring it back on. I intend to bring it back on Monday. Generally, I done. And you shouldn't worry about your grades as I see right now, but I just noticed that we have more than one tough graders. It doesn't mean that everything is bad, but a little less generous than average. Which means either the work that was graded was a little less than perfect, or the grader is really tough. Be generous to each other. Okay. So I think this one will be the last math intensive homework, and it will be due on the next Wednesday. In some sense, we already did number one in class, so basically one needs to copy paste it from the class and give verbal explanation. The number 3 is to do the exercise which is similar to problem 4 from already accomplished homework. So we were establishing connections between arbitrary operator and the operators that we are aware of, right? And in the new homework, the task is to use the creation and annihilation operators in order to construct position, momentum, kinetic energy, potential energy, and total energy. It's partially in the lectures, but it needs a little bit of critical and creative thinking. Not much. It's doable in like 3 minutes. Okay, number 4. Everyone can do it without any help immediately, but if we wait until coming Monday, I'll probably give more hints, and it will be also like 3 minutes task. Okay. What else? So tonight we will complete everything which is missed for your presentations. I expect the slides on Thursday night. So it is not because I want someone not to sleep, but it will be a little messy if everyone comes with a memory stick, plugs it in. We will spend a lot of time, and we want just to stay on schedule. And also, I would prefer to give a brief glance to review of your submissions and give some suggestions of quick corrections if something is needs corrections. On coming Monday, I'm asking you to do one more surprise homework, but if you will be not calculating, it will be basically taking notes during your listening to each other, right? I hope you didn't get too irritated of making this assignment. And there will be the very last homework in about after or correlated with this one, where I will ask everyone to mimic research process for maybe the very simplest example, like free space, and the same protocol as we later will do for each individual projects. So it's not challenging, it's not hard, it's just making sure that we are on the same page. So so if I didn't miscount, total number of homeworks is like 10 or less. Okay. I can, if you really want, I can speak about class material, but maybe let's vote if you're okay to have just a little early lunch. Who wants to stay here longer? Who votes for early departure? Okay, accepted by total majority. Okay, thank you for investing your time and looking forward to see you this evening. Joshua, Ellison, do you have any questions, or you let me disconnect?
I'm good, thank you.
Okay, yeah, thank you, Ellison. Joshua, do you have any questions? More questions one, more questions two, more questions three. I'm going to disconnect.